Hello, welcome back to the channel. So let's do one more question on the calculation of definite or indefinite integrals using substitution. So if you have not watched my previous videos, I would highly suggest you to first watch those previous videos in order to get the full context of what we are doing in this video, because we will be using some concepts that we already covered in the last videos. So before solving this question, let's do a brief overview of why we have to use substitution or when we have to use substitution for some of our definite or indefinite integrals. So if you want to get a hint or a trick about when you will use substitution in order to solve these definite or indefinite integrals is whenever in your integral expression you have a function for which you are also provided the derivative of the function attached to the same integral expression, you will use substitution. In other terms, if you have a function for which you also have a derivative to that function in the same integral expression, you will use substitution in order to solve definite integrals, definite or indefinite integrals. The catch about definite integrals, as we also covered in the last video, is that an additional step is done basically when you are evaluating definite integrals using substitution, is that you also have to change your endpoints based on your function transformations. But in this case, since we are calculating an indefinite integral, we won't really need that part in order to solve this question. So let's look at this expression first and see if we have a function for which we also are given the derivative of that function in the same expression. So if we look over this expression, I have two square root log x terms in my integral expression, right? So that gives me a basic idea that I can take my first guess to be the square root log x function and see if the derivative of that function is also in the same integral expression. So let's start with going forward with just the square root log x function. So let's assume that function is represented by u, and that function, the first guess is under root log of x. Let's take the derivative of this function with respect to x. So if we take that derivative, we will have to use chain rule. So the square root of something, the derivative of the square root of something is 1 by 2, the square root of the thing which was in the expression, and since in this case we also have a function inside the square root, we'll have to use chain rule in order to calculate the full derivative, which would be done by also taking the derivative of log of x in this case, and that is completely done using chain rule. Now if we evaluate this expression, it is 1 over 2 square root log of x, d by dx of log x is 1 over x, and the final expression would be, if we simplify it further down, it would be 1 by 2x times 1 over square root log x. And you can clearly notice both of these expressions over here, right? You notice the square root log x, which can be changed to u, and we also notice 1 over 2x square root log x term over here, which we can just substitute as du by dx in this case, right? So let's try doing that. First of all, since we calculated du by dx as 1 by 2x square root log of x in this case, let's shift the dx to the other side. So du would be equal to 1 over 2x square root of log of x dx in this case, right? So you have this expression, and now let's write our original indefinite integral in this case. So the original indefinite integral in this case was e to the power square root log x upon 2x square root log x dx, right? That was our original integral expression over here, right? So now we just have to make all those function transformations. Our root of log x will be changed to u, and this expression, which is over here, will be simply changed to du in this case. So if we make all those transformations, it would be e to the power u, and this expression would be changed to du in this case. And now in this case we are calculating the integral of e to the power u, which would be simply e to the power u plus c. But now keep in mind that this is not your final answer. You will have to perform one more step. Since you converted all those transformations to u, in the final answer you'll have to convert all those transformations from u back to the x notation as well. So since u was originally square root log x, so you'll substitute square root log x instead of u, and that your final answer would be e to the power square root of log x plus c. And again, you don't have to forget adding the constant of integration, because you were calculating an indefinite integral, and whenever you're calculating an indefinite integral, you have to also add the constant of integration. So there were two important points that we covered in this video. So the first important thing that we covered in this video is, whenever you'll get the final answer which will be based on your new functions, you'll have to convert all the new function transformations to the original expression ones. In the same way we converted u again back to the x notation in this case. And the second important point, whenever you're calculating indefinite integrals, you have to also consider the constant of integration. In this case, you also have to add the constant of integration because it's an indefinite integration. So that's it for this video. I hope you found this video useful. Feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.